A potentiometer, or even simpler pot, is a manually adjustable variable resistor with 3 terminals. To be more specific, we can say that 2 terminals are connected to the ends of a resistive element, and the third one is connected to a wiper that slides over the resistive element. Therefore, the wiper position defines the output voltage. These are the symbols used in circuit drawings. Left is the American standard and right the international one. Here you see another example of a potentiometer, and I will explain more in detail how they function with this schematic drawing. There is a resistive element that can have different constructions, such as carbon composition or wire wound. Then there is a wiper that rotates and slides over the resistive element. There are 3 terminals. One is connected to the wiper and the other 2 to the ends of the resistor. The complete mechanism is protected by a housing. The potentiometer can be used as a voltage divider to obtain a manually adjustable output voltage at the slider from a fixed input voltage applied across the 2 ends of the potentiometer. This is the most common use of them. The circuit has a voltage source, Vs, and a load with a resistance, RL. In this case the load is a lamp. We have connected the first terminal to the positive leg, the second to the wiper, and the third one to the negative lead. Now we created in a potmeter 2 resistive pads. Basically, we could say that each represents a separate resistor. To make our representation simpler, we replace it with resistor R1 and R2. If we change the position of the wiper, we change the values of resistor 1 and 2. We can also see that the current through our lamp changes, causing it to light up. With basic network theory for resistors in series and parallel, we can calculate the voltage across the load. Suppose that the load resistance is much higher than the potentiometer resistance. The formula can be simplified into VL is R2 divided over R1 plus R2 times Vs. If the wiper is on one end and R1 is 0, it means that the voltage through the load is the same as the source voltage. If the wiper is on the other end, R2 is 0, which causes the load voltage to be 0. This ability to adjust from 0 to 100% is an advantage of the potentiometer over a variable resistor in series with the load. The second advantage of the potentiometer over the rheostat is that the ratio of resistance of the potentiometer and the load is less critical. For the rheostat, a big or small load could make the rheostat resistance excessive or negligible. When selecting a potentiometer, there are some important characteristics to take note of. The taper is the ratio between the wiper position and the resistance ratio. The most common are the linear taper and the logarithmic or audio taper. A marking code on the device indicates its resistance value. If you see, for example, 100K, it means the resistance is 100 kiloohms. Also, other marking systems are used, such as the SMD marking with 3 digits. In this case, the first 2 digits indicate the resistance value, and the third the multiplication factor. So 10 ohms times 10 to the power of 2 is 1 kiloohm. The taper is marked with a number, which is different according to the part of the world. A good practice is to check the value in the taper by measurement. If we turn the wiper, the value changes. The smallest possible change we can measure is called the resolution. An example of a good resolution are conductive plastic potentiometers, while wire wound has often less resolution. Also, the wiper design influences the resolution. On the ends of the resistor, low resistance metal parts are connected. When the wiper enters these parts, there will be a jump in resistance. This is called the hop-on or hop-off resistance. Potentiometers are constructed in many different ways. I will shortly go through the main variations. The most common type are the rotary ones. The single turn pot is the most common rotary pot and can usually rotate 3/4 of a full turn. The multi-turn can make multiple rotations. 5, 10 and 20 are the most common. Because of the longer travel, the precision is higher. A dual gang has 2 resistive elements connected to one shaft. In this way, 2 channels can be set at the same time. A concentric pot is also a dual pot but has 2 concentric shafts. Both pots can therefore be adjusted separately. A servo pot is motorized and can be actuated by a motor, and usually also by hand. The second category is the linear potmeter. The slide pot has a single linear wiper and is also known as fader. A dual slide pot has one slider that actuates two potmeters in parallel. A multi-turn slide is adjusted by rotation. A spindle transforms the rotation in a linear motion of the wiper. And finally, a motorized fader is actuated by a servo. The third category is the digital potentiometer. These are controlled electronically and exist out of an array of small resistive elements in series. Each of these elements has a switch. Therefore you could say that these switches function as a virtual wiper. The fourth category is the rheostat. Basically it is a single variable resistor. If we take a potentiometer and we connect only the wiper and one of the other terminals, we created a rheostat. For the resistive element, different materials can be used. Carbon composition is most common, has a low cost, and a reasonable noise and wear. On the downside, they are not very accurate. The wire wound can handle high power, is durable and long-lasting, and can be very precise. They are often used in high power applications. The drawbacks are the limited resolution and the rough feel. Conductive plastic has a very smooth action, the highest resolution and a long life. Unfortunately, they handle only low power and can be expensive. They are often used in high-end audio applications. Cermet is very stable, has a low temperature coefficient and can handle high temperatures. On the downside, they are expensive and wear out faster than other types. They are often used for trim pots, which do not have to be adjusted often. Potentiometers are used in a wide variety of applications. For example, in automotive, the throttle pedal is often a potentiometer. Another example is joysticks for machine control. Volume control is often performed with a motorized potentiometer in audio applications. For balance control, a dual gang potentiometer can be used, where one gang has a logarithmic taper and the other gang has an inverse logarithmic taper. Potentiometers are often used as position or angle transducer to measure distances or angles. In fabrication and calibration, trim pots are often used. Trim pots are preset potentiometers, which are often mounted on a circuit board and can be used to tune or adjust the circuit's performance. They are used only during calibration of the system and are at a fixed position most of the time. If you want to learn more about potentiometers or other resistor types, please visit resistor.It.com.